The mystery surrounding the Manhattan-sized object racing through our solar system has captivated scientists and the public alike, as speculation continues to grow over whether it is a simple comet or something far more extraordinary. The interstellar visitor, officially designated 3I/Atlas, spans an enormous 19 kilometers across and was first detected by the Atlas telescope system in Hawaii on July 1st. From the moment astronomers identified it, the object has stood out due to its speed, trajectory, and unusual characteristics, stirring curiosity and prompting intense investigation. As only the third known interstellar object ever observed passing through our solar system, following the already famous Oumuamua and Comet 2I/Borisov, each piece of new data fuels fresh debates and theories about its origin and nature. What makes 3I/Atlas particularly fascinating is its hyperbolic trajectory, meaning it is not bound to the sun's gravity and will only swing through our planetary neighborhood once before returning to deep space. This path indicates that it originated from somewhere far beyond our solar system, likely from another star system entirely. According to astronomers tracking its movement, the object is expected to reach its closest approach to the sun between October 29th and October 30th. After that, it will continue on its outbound course and make its nearest pass to Earth on December 19th, remaining at a safe distance of about 274 million kilometers. Although at no risk of colliding with Earth, its unique behavior makes it an invaluable scientific opportunity. Scientists largely agree that 3I/Atlas behaves like a comet, shedding gases and dust as it approaches the sun. Yet, a number of irregularities have caused some researchers to question whether this is the full story. Among the most notable voices is Harvard astrophysicist Avi Loeb, who has long argued that certain interstellar objects may represent probes or technology from extraterrestrial civilizations. Building upon ideas like those raised during the study of Oumuamua, Loeb suggests that unusual motion or acceleration might point to non-natural origins. While many scientists disagree with such interpretations, they acknowledge that interstellar visitors can display unexpected behaviors that challenge standard models. Adding to the intrigue, renowned physicist Dr. Michio Kaku recently commented on the object's significance. Writing on the platform X, he described 3I/Atlas as a mystery interstellar object noted for its hyperbolic path toward the sun and very high speed relative to the solar system, emphasizing that the upcoming days may bring crucial insights. Dr. Kaku explained that while many view the object as simply another comet passing through for the first and only time, others believe there may be more at play. In his words, a faction within the scientific community is urging caution and encouraging open-mindedness, raising the possibility that 3I/Atlas could be a visitor of an intelligent origin. Although these ideas remain speculative, they add a dramatic dimension to the scientific investigation. One of the key factors that could help solve the mystery lies in how the object behaves when it passes close to the sun. Dr. Kaku explained that scientists will be paying extremely close attention to whether 3I/Atlas gains energy during its solar encounter. Under normal physics, objects moving under the influence of gravity and sunlight follow predictable energy patterns. As he noted, the energy in must equal the energy out, and deviations from this principle would demand explanation. If 3I/Atlas were to accelerate in a way inconsistent with gravitational forces and expected comet behavior, it might hint at some form of propulsion or intelligent control. This unusual concept relates to the Oberth effect, an important principle in astronautics. The Oberth effect describes how a spacecraft can gain additional kinetic energy by firing its engines at high speeds or near a strong gravitational field, such as when slingshotting around a planet or star. The idea is often used in space missions to conserve fuel while achieving maximum velocity. Dr. Kaku draws a parallel between this principle and what scientists are looking for in 3I/Atlas. If the object were somehow generating or receiving an extra push during its solar flyby, it could imply that it is not simply a natural comet, but possibly a craft or structure capable of controlled maneuvers. Although the scientific community maintains cautious skepticism, The possibility of detecting any anomaly has sparked widespread interest. Astronomers, observatories, and space-based instruments around the world are preparing to gather massive amounts of data during the period around October 30th, hoping to capture any subtle changes in the object's motion, outgassing, or energy signature. High-resolution imaging, spectral analysis, and trajectory mapping will each play a role in building a complete picture. These observations may finally provide answers to questions that have persisted ever since the object first appeared on sensors. Part of what makes the case so compelling is humanity's increasing ability to detect and track interstellar objects. Prior to the discovery of Oumuamua in 2017, scientists theorized that interstellar debris should occasionally enter our solar system, but such objects had never been observed. The detection of not just one, but now 3 of these travelers within a relatively short period has heightened scientific excitement. For researchers, each new object offers a rare glimpse into the materials, structures, and dynamics of distant star systems. Unlike comets native to our solar system, interstellar comets are shaped by environments far different from our own and may carry clues about the early formation of planets and stars. However, it is the speculative, almost sci-fi element that has captured global attention. Even the slight possibility of an artificial origin invites comparisons to past debates about unidentified aerial phenomena or mysterious signals from space. Scientists acknowledge that extraordinary claims require extraordinary evidence, and so far, no observations definitively point to artificial construction. Nonetheless, the willingness to consider unconventional hypotheses reflects a growing openness within parts of the scientific community to question assumptions and explore the unknown without prematurely dismissing possibilities. As the object approaches the sun, theories continue to circulate. Some researchers have suggested that the irregular features of 3I/Atlas could result from its composition or surface properties. For example, it may contain volatile materials that respond differently to solar radiation than typical comets. Its long journey through interstellar space may also have altered its structure, causing unpredictable outgassing patterns. Others propose that interactions with interstellar dust, cosmic rays, or micrometeorites could be responsible for its unusual behavior. Such explanations fall within the realm of natural physics, yet they highlight how little is known about bodies formed beyond our solar neighborhood. Meanwhile, the public imagination is fueled by dramatic headlines and comments from respected physicists. Dr. Kaku's suggestion that the object might reveal signs of extraterrestrial intelligence has amplified interest worldwide. Many wonder whether humanity could truly witness evidence of another civilization, especially if that civilization possesses technology advanced enough to traverse interstellar distances. While mainstream astronomers stress that the most likely explanation is still a comet, they understand why such possibilities captivate millions. Events like this highlight the universal human desire to understand our place in the cosmos and to know whether we are alone. As October 30th approaches, anticipation grows. Scientists will observe the object's velocity and trajectory down to the smallest measurable change. Even tiny deviations from predicted paths could have enormous scientific implications. If no unusual energy gain is detected, then the comet hypothesis will be strongly supported, reinforcing current understanding of interstellar visitors. If, however, any anomalous acceleration appears, it could mark one of the most extraordinary discoveries in human history. The world would likely debate and scrutinize the findings intensely, with researchers demanding rigorous confirmation from multiple independent observatories. Regardless of the outcome, the passage of 3I/Atlas represents a rare and invaluable opportunity for science. Its brief visit allows researchers to test theories, refine detection techniques, and expand knowledge about the diversity of objects traveling through our galaxy. Whether it proves to be an ordinary comet with unusual quirks or an object of deeper significance, its journey through our solar system deepens humanity's continuing quest to explore the unknown. The next few days and weeks could bring answers or raise new questions that challenge our understanding of what lies beyond the borders of our sun's reach.